Well, I'm back. Hopefully we can get this finished up in this segment. So we're loading up sulfur dioxide in the plots view. I had to reboot my computer. So they're giving me a lot of trouble today. They just, most of the time I have this kind of trouble trying to do these videos. I was surprised that I didn't have technical difficulties Thursday night. So okay, so our data goes back to the 11th through today, and then it'll have a couple of days forecast period. This is sulfur dioxide with the global view, and our readings are in parts per million. This olive color green is 1 parts per million, and then the cream colored is 2, and then the gold color is 5, and then the darker gold is 10, and then 20, 50, 100. So, and then that's 999 over there. So let's run this movie, and I'll move the map around so you can see what's going on in your neck of the woods. Here's Hawaii with its continual outpouring. This is Mexico, southern Mexico. This is the Galapagos Islands. They've been having eruptions for the last couple of weeks. They were in the news and now they're not. I just don't understand. And this morning we had another eruption from Hawaii. You're going to see it coming up. Boom, right there. And it happened at the Galapagos at the same time. If you'll look at that when we run this movie back again, you'll be able to see that. But you can see once the sulfur dioxide goes up into the air, it separates into different things and particulates, and sulfuric acid is one of them. And so when it rains, did you see that? That's in the forecast period. Up here in Alaska, there's an active volcano going on, doing stuff up there. So it just started again. So I'm moving it over so we can see Australia and the whole Ring of Fire area. Now, when we have volcanic and earthquake geologic activity, sulfur dioxide is one of the main things that is released. We have sulfur dioxide, methane, and ozone. Those 3 greenhouse gases are released. Now, if you'll look, down on off the Ross Sea, there's that volcano that's releasing some sulfur dioxide. That's Mount Erebus down there where it goes gold at the bottom of the screen. Now let's move this over so we can look at the wildfires. This is the wildfire area in Siberia, and sulfur dioxide is one of the greenhouse gases that's created during fires. The ozone is a big one with fires too. So there's that. So you get the idea on sulfur dioxide. Now let's go to ozone. And it defaults to total column. And if people don't know about ozone, I'd like to refer you to my 3 videos, informative videos that I did on ozone. And this data, I'm sure it goes back a few days. I'm sure it's current. It usually is. Right. Okay, this is over the North Pole. And we can look at the South Pole too. So this is from the 11th to the 15th. So this data is current. Now one thing that is disturbing, and it defaults to total column. One thing that is disturbing is this is the North Pole, and you can see a thinning even going on the north around in the Arctic. You can look down here on the chart. It's measured in Dobson units, or DU, and this 225. These are like millimeters. It's equivalent to millimeters of thickness of ozone. Like if you have like 300 DU, that's equivalent to 3 millimeters of ozone through the column. That's protecting us from the ultraviolet radiation. And I'd like to thank the my subscribers that are writing in with all this great data and information. And I mean, these people, they've got to be scientists that have this information, and maybe they've even written some of these papers. And if people want to contact me directly, the best way is to go to my website, margoshealingcorner.com, and I have a contact button, and you can just hit the contact button and it will take you to a form that you fill out, and you fill out the form with your name and your email address and your message and submit it, and I'll get it, and then I'll respond. I respond to pretty much all the emails, but that's how people can, if they want to continue a conversation or want to have some information or want to ask me a question or just want to say thank you, I like your work, you know. I love getting emails. So, okay, here's the South Pole, and they're in winter time, so this is where the ozone hole, or the thinning, it's supposed to be the thinnest part in the winter time down there, which is summer here, is supposed to be down here over the South Pole, but what I've found is quite disturbing in that the thinnest part is not over the South Pole now, but it's around the middle of the Earth. And while that's loading, I'll show you. See that blue? That's 225 DU, and that's very low. That's very low, and it's very thin, and then even going up into the 250, 275 range, that's still very thin, and it still lets through lots and lots of ultraviolet radiation, and that's what's causing so many skin cancers and skin problems, and your DNA is unwinding, and I mean, it's a whole laundry list. So this is serious stuff. So we can see how it does move around. It's not constant. It doesn't stay in one place. It does move around. But there are patches where it's thicker than other places, because you can see, like in the orange and red, it's quite a lot thicker, which frankly I'm surprised at, with it being winter down there. I thought that it would be not as thick all the way around here too, but because that red is like 425 DU. So there's your South Pole, just in case you wanted to know how the ozone hole is going. So let's load this data for the worldwide, and this is total column. This is good ozone that's blocking out the ultraviolet radiation from the sun and cosmic rays and x-rays and things like that. And you can see on the South Pacific it's not looking good, and there's this constant thin point over Ecuador, and over the whole middle part of the United States, where the equator runs, is absolutely the thinnest, and then it's thin up here. I'm thinking these are the Himalayan mountains because they're so high, and Tibet and everything. And then you can see it green, which is thin up over Norway and Finland and up over Russia and Siberia, and that's disturbing. It's thinning. It's getting much thinner over the Arctic, which means that sea ice is going to be melting even faster too. So now let's look at surface ozone, and that's considered bad ozone. There's good ozone and bad ozone, and I explained that in my videos. And the surface ozone is created as a result of the sunlight coming down through the atmosphere and interacting with the pollutants in the air, creating this bad ozone that causes all kinds of health problems and things. And here's that green area over Greenland that I was talking about. Now this is measured in parts per billion down here, and the EPA says that if it's over 70 parts per billion, it's unsafe to breathe it in such high concentrations for more than 8 hours. Over 70. But if you're sensitive, like I am, with someone with asthma or respiratory issues, even less than that would cause you problems. So you can see in the daytime when the sun comes up, like over here in the United States and Canada, it gets quite high, and then it gets quite high on the other side of the world too. Now let's do a little zoom in and see if we can